today we're going to be talking a bit about using metaprogramming to debug issues that would otherwise be extremely difficult to figure out. Now, speaking of difficult to figure out, I want to say up front that there are a few bugs in my Keynote animations. How many of you have done a lot of CSS or a lot of SQL? So, like, we know that when we're programming declaratively, like in CSS or SQL, or it turns out Keynote, it's incredibly efficient about 95% of the time. And then there's that 5% where you and the interpreter have a very different opinion about reality. And I'm bringing that up not just as a disclaimer and an apology, but actually as a content warning. If you have cognitive issues or other sensitivities that mean that seeing stuttery animations might be difficult or dangerous for you, I unfortunately cannot promise that my talk is going to be entirely free of that. I'm sorry. So continuing on in the spirit of talking about bugs, it's time for another scary debugging story. I know it's like a whole 3 weeks after Halloween and we're supposed to be over that now, but bear with me. About a year ago, I was working with a consulting client on a Rails major version upgrade. In the course of this project, we encountered complicated metaprogramming that interacted strangely with the Rails autosave internals. This metaprogrammed code had been written about a decade before by contractors who'd worked on the original Greenfield site, many of whom left the project shortly after and had not been there at all in the intervening decade. It all started when the tests failed with this one obscure error deep into the Rails internals with a stack trace about 3 screens long. We tried Googling, but Stack Overflow was completely useless. There was this one GitHub issue for Factory Bot that kind of looked right, and we thought maybe, because we had just switched from Mechanized to Factory Bot since Mechanized didn't work with Rails 5. But following up on what that issue told us didn't pan out either. And so we were in an unhappy place. And right now, you're probably guessing in your heads about the epic road ahead of us. Maybe it took us a few days to solve this, a few weeks. Nah, 2 hours. There wasn't that much of a trick to it, even. We knew that the problem we were seeing was can't modify frozen hash. We knew where we were seeing that problem. The trick lay in realizing that that was not a useful thing for us to understand in the moment. What we really needed to know, instead, was where the hash froze. You can't rewind time from an error, but you can add debugging logic when you're replicating a bug. We were able to use some simple, light metaprogramming, just the contents of this page, to insert this debug code and identify where the hash was freezing. We followed a pretty simple process. It fits on a slide. We added some telemetry, and then later on, we looked at the relevant data that the telemetry had surfaced. This would honestly be a very boring story if it weren't for the fact that it involved metaprogramming and the fact that it turned a 2-week bug into a 2-hour one. Now, right now, some of the more pedantic among you may be wondering where the metaprogramming is. And so I'd like us to take a quick moment to define metaprogramming. Y'all may be worried that this is a horrible tangent detour mess and that this talk is careening off the rails. Now, when I was practicing this talk in front of my team at work, I hadn't written my speaker notes yet, and I was kind of improvising. I said that off-the-rails bit entirely straight-faced without intentionally making a pun, but then my teammates laughed like I'd done it on purpose, so we're all stuck with that joke now. Anyway, this talk is going to concern itself with 3 questions. First off, how do we define metaprogramming in the context of Ruby? It turns out that the way that metaprogramming works in Ruby is pretty different than how some other languages do metaprogramming, and that that's actually related to why Ruby is sometimes hard to debug with other languages' tools. After that, we're going to look at some peculiarly Ruby-ish ways that we can use metaprogramming to investigate what's going on inside the Ruby VM. And then finally, we're going to return to the story I just told you and examine it in more depth. We'll talk about how we can apply these investigative metaprogramming techniques, IRL, to root out bugs' root causes much more quickly than we could otherwise. So for starters, what is metaprogramming? When we talk about metaprogramming, we tend to superimpose two definitions in our heads. There's the academic definition that we're taught to use in technical interviews. And then there's a slightly more pragmatic definition that is how most of us actually think about metaprogramming. One of the common academic definitions is code that modifies the structure of the program at runtime. And according to some extensive Twitter research on my part, the most common pragmatic definition is code I can't analyze using full text search. What's interesting to me is the way that these definitions conflict. There's a hole you can drive a Mack truck through, and that hole is the existence of the send. In Ruby, we don't really call methods on objects so much. That's just syntactic sugar, which is to say a lie we made up to make Ruby look more like other languages. In Ruby, we send messages to objects, and then those objects decide how they want to react to those messages. Whenever you call a method in Ruby, it's really just an alias for calling send. This means that if part of your code base calls send with a variable value rather than a static value, you can't use full text search to determine all of the places that methods on that object are used. Using send with variables falls firmly within most people's practical definition of metaprogramming, even though it doesn't do anything like modifying the structure of the program at runtime. And so, okay, maybe we can get out of this hole by trying to modify the academic definition. Maybe we can modify it to be more inclusive of send. Maybe it's not just code that modifies program structure at runtime, but also code that determines the method to be invoked then. Oops, that definition is even more vulnerable to having holes poked in it. Is there any practical distinction between determining the method to be invoked at runtime by using send with a variable and determining the exact same thing with an if statement? Not to me. Not from a theoretical perspective, anyway. Like, yes, you can full text search for one and not the other, and that is a very real difference. But it's not a difference that can be captured easily by talking about this in terms of what happens when. And while I'm playing the well actually game on my own talk, I'd like to also zoom in on this at runtime business. Ruby's an interpreted language. In interpreted languages, sometimes the distinction between load time and runtime breaks down. And some things about the structure of Ruby make that difference especially meaningless. So let's take a zoom into the Ruby interpreter and how it loads a pretty basic class. We've all written code like this before. Simple class, one getter, one setter. After a Ruby file has been parsed, the interpreter goes through the generated abstract syntax tree node by node. It gets to the node that defines a class, and it builds a class within the virtual machine. Then, every time we define a method, it adds the method to the list of instance methods for that class. But under the hood, it's actually doing something a little more like this. It's building Ruby objects. In Ruby, when we define a class, what we're actually doing is instantiating a class object. When we define instance methods, we're adding methods objects to the array of instance methods that that object tracks. Now let's look at an equally vanilla Ruby class, but one that uses the attr accessor macro to define its getter-setter pair, instead of defining the same pair manually. Class macros are definitely something that a lot of people think of as metaprogramming. But because attr accessor is so common, it's something we type every day. It's easier for us to not think, oh, this is metaprogramming, capital M. It's scary. And so we start again by defining a class, whatever. But then we hit the macro call to attr accessor. Attr accessor is a method. We're sending the attr accessor message to the yarn class when we call it. And so now we need to look that method up. Attr accessor isn't defined on the yarn class itself. And so we have to go into its ancestor chain now to look up the method. Yarn is an instance of class, and attr_accessor is defined as an instance method on class. So that's the definition of attr_accessor we use to define a getter-setter pair. Attr_accessor then calls define method twice to define that getter and setter for the attribute name, in this case length, that we've passed into attr_accessor. This definitely feels a little like metaprogramming. We're calling define method. We're using Ruby methods, like define method, to define the structure of our program. And so my question is this happening at runtime or at load time? My answer to this is that that's not a meaningful distinction in Ruby. We're using Ruby to load our classes. And so it's all a big mismatch. It's all happening at once. The definition we're taught to use for metaprogramming, code that modifies the structure of the program at runtime, works in other languages. It's like a really great definition for how Java metaprogramming works. But in Java, a program structure is different than the data passing through the program. And Java also has a defined compilation phase that has to complete before you can run the program. In Ruby, neither of the assumptions underlying this modifying the structure definition is actually true. Ruby uses Ruby to build up the underlying structure of classes and methods that we invoke, and treats classes and methods as just other kinds of objects. So in Ruby, the best academic-sounding definition of metaprogramming that I can come up with is code that modifies the thing that we would call program structure if we were using another language, just like it modifies the data passing through the program. Now, this definition is a lot more compatible with the pragmatic definition that all of us actually use when we're thinking, oh God, Ruby magic. And that's because at its core, the pragmatic definition is not about full-text search. Instead, it is about feelings. The pragmatic definition is about our feelings in the face of code that resists analysis via full-text search. And these feelings are, at least when I have them, about approximately, oh my God, I don't know what's going on. Why? How am I ever going to debug this? Oh God. And these feelings are also why people from strongly typed language backgrounds often find Ruby a bit tricky at first. When you're used to having a compiler warn you off of certain kinds of type bugs, it's really intimidating to program in a language that doesn't offer you the same assistance. These feelings are ultimately about not having the tools we're used to from other languages, just as we can't rely on the same idea of program structure as distinct from data that is present in other languages. And this is even true if Ruby was the first language you were taught. This is true even if Ruby is the only language you know. And that's because all of us were taught Ruby within a paradigm that believed that program structure and program data are different. That paradigm exists because that was true in BASIC, that was true in Pascal, that was true in Java, that was true in the traditional first languages that most people learned. Now, there are two places that we can take this reality that we were taught Ruby wrong. And one of them will be blaming the victim. One of them would be saying that, okay, real programmers, whoever those are, do not need tooling to help them understand what the heck a program is doing. And I'm not about that. I do think we still need tools. But I think we need Ruby tools. And I also think we need them to be tools that we can use today. Stripe spent several years trying to develop a gradual type system for Ruby. And don't get me wrong, I think Sorbet is an amazing piece of engineering that is pushing Ruby forward. But the average organization does not have the time or developers to assign 3 people to make a type system for 4 years. The average organization just can't engage in a tool-making effort that's that extensive. We also need these Ruby tools to be tools that can deal with Ruby code bases as they are. I have worked in a lot of decade-old code bases where you can date any given piece of code by the style it was written in. Our community's opinions on how to write Ruby well keep changing. If my tool set only works with a specific dialect of Ruby that I have defined as good Ruby, then that limits me as a developer. It means that I can only work within some arbitrary, personal, and fashion-dependent notion of good code. It locks me to a particular point in time. So the correct tool, I think, is applying more Ruby to the problem. It's to fight other people's metaprogramming with metaprogramming of our own. And I mean that both in the hand-wavy Ruby magic sense of code that violates our expectations about static program structure, like using prepend to override a definition, and in the stricter sense of code that treats structural elements, like the current stack trace, the same way it treats data and functions. If we can manipulate structure like we can data, then that means that we can assign structure to a variable. That means that we can print that variable out when we're debugging, and that's cool. One of the most powerful things in computering is giving up on trying to be smart, is giving up on trying to predict what the computer will do, and instead just asking the computer what's going on and observing the results. And so now we're going to look at 3 basic ways that we can leverage Ruby's dynamism to help us understand what's going on in our programs at runtime. The first of these is reflection, which is computer science for asking a program about its structure. The second is using dynamic language features to record what our programs do when. And the third is using those same features to help us more efficiently review what has happened. The most basic way we can use reflection in Ruby is calling self to understand what the current object is. And then we can kind of proceed from there. We can ask self what class it's an instance of. In this case, a wool yarn instance turns out to have a class of wool yarn. This isn't necessarily very interesting information in itself, but we can move on from here to some really cool places. For example, once we have a class, we can look up that class's ancestor tree. Once we have an ancestor tree, we can see which of a class's ancestors define a given method. And then once we have that, we can even look up all the places within our code base that that method is defined. It's kind of like full text search, but it's a lot more Ruby-ish. And then from there, just within Ruby, we can even print out all of the possible method definitions. So here, we can learn that the subclass wool yarn completely overrides the definition from the fiber class, which is good, because that definition would have just raised an error. Like I said, some bugs in my animations, it's fine. Now, I'm just scratching the surface here. There are a million things that you can look at about any given object or binding in Ruby. I'd encourage you to open up IRB or a debugger and just kind of play around. Call .methods on things, which tells you what the methods on that object are, and then call some of those methods that look metaprogramming-y, and see what happens. However, after a while, you are going to get sick of typing yarn.methods minus object new.methods to see what methods that are like normal looking are available for an object. In these moments, you are either going to be tempted to find a gem or tempted to build a gem. Pry exists. Pry does a lot of work for you. Pry is great. Past using Pry, I would actually kind of suppress the instinct to gemify things. What I'd instead suggest is storing some of the one-off methods that you use for analysis in an IRBC file, an IRBRC file, or a PryRC file. This way, they'll be loaded whenever you're at a REPL prompt. And the reason I'd suggest this is that ultimately, using metaprogramming techniques to explore what your code is doing is about expanding your understanding, both in the moment and by training your gut, of what Ruby is doing. You can import a library for making HTTP connections more conveniently, and have that work out great, because you can make 99% of API calls just fine without understanding the intricacies of HTTP as a protocol. The goal with using most gems is to shield you from needing to know stuff, and honestly, I kind of love that. But if you're shielding yourself from needing to know stuff, it's pretty hard to learn that stuff at the same time. You can't just type require and suddenly understand Ruby's object model better. So anyway, moment of philosophy over, let's talk about recording. Recording is about understanding your code over time. It's about taking snapshots of what has gone on so that you can understand later behavior better. There are two big ways that I like to insert recording logic. We can use prepend to tack additional logic into a class, or we can use the Tracepoint API. Now, Tracepoint is an enormous topic, and it could consume an entire talk in itself very easily. So I'm just going to go over a basic example now. Tracepoint organizes itself around events. And one of those, the most useful one in my opinion, is another line of code just got executed. Being able to trace this is super powerful. For example, in this code, we insert like a very simple if statement, very jankily, that compares a value to a tracking variable that matches its previous value. If that value of that variable changes, then we print out where it changed. Now, as important as how we insert telemetry is where we store the results of that telemetry. The simplest form of this is just putting in a variable, whether this is an IVAR or a global variable. Yes, by the way, Ruby has globals. We don't see them very often in production code because in production code they're a horrible idea. But this is debugging code, so who cares? You can also put information into a logger, and this gets really powerful when it's a relatively smart logger that puts information into a searchable or filterable format. One question I've been asked is where you should even put code like this, because it doesn't fit nicely within your existing project structure. And my most honest answer is whatever works for you. What I personally do is I'll either make a file in the initializer directory of a Rails project called debugging.rb, or I'll make something similar in a test support directory. I never check this file into Git, and half the time I delete it after I found the problem. If a similar technique works well for you, great. If something else works better for you, then run with that. I don't really think there's a right or a wrong way to do this. Now finally, let's talk about reviewing the things we record. There are two basic ways to do this. One is inserting a debugger breakpoint, and the other is adding a put statement. And some of you are probably groaning internally right now because you are probably already doing these things. But the dynamic nature of Ruby means that you can do them conditionally, and that's really cool and really efficient. How many people here have inserted a bug into their code and then noped right back out when it turned out that that code was called a lot more often than they thought? I'm seeing a lot of hands, a lot of laughter, yeah. In other languages, you insert debugger breakpoints in your IDE, and they always trigger, no matter what. But in Ruby, calling binding.pry or calling bybug is just calling another method. So we can trigger debug breakpoints if and only if a given flag is true. We can add breakpoints or add put statements at the site of errors. So now let's look at these things in the context of solving real problems, like the bug I mentioned at the start of this talk. What's important to remember here is that our goal is not to understand everything that our program is doing. Our goal is to fix bugs. That means our goal is to figure out the cause of the bug. Bugs are caused by what we thought would be true crashing into what is actually true in the real world. And so to isolate the cause of a bug, we need to systematically identify things we think are true or that might be true, and then figure out a way to prove whether they're true or not. In this context, investigative metaprogramming is a technique for expanding the number of questions that we can answer in a reasonable amount of time. Here, the question we're trying to answer is, did the hash freeze correctly, or did it freeze inappropriately? In order to answer that question, first we need to answer the smaller question of, when did the hash freeze? There's a naive way of doing this, which is to just print out a message whenever the hash freezes, and we totally tried that first. Rails freezes hashes a lot. Turns out, we'd assembled ourselves a whole haystack of print statements. Sorting through that haystack to find a single needle was going to be way more time than it was worth. We had a reviewing problem, in other words. We're not filtering enough when we're reviewing the data. In order to solve reviewing problems, it can help look for vague places in the question we're asking. we're not asking when is a hash freezing. We're asking when the specific hash that is throwing the error is freezing. And so the appropriate way to review this information is to do something at the error site. What that is, we might not be sure yet. But that's fine, because that is a recording problem. We can think about recording problems by thinking about the actions we want to record. In this case, we're interested in when the hash is freezing, and so we instrument the freeze method. And so now the question is, what do we instrument that with? You're guessing right, that's a reflection problem. We solve reflection problems by thinking out about what data we're trying to collect. In this case, it's when the hash is freezing. And so the stack trace is the most useful piece of information. By using this technique, we are able to pinpoint the exact place where an association was being deleted when it shouldn't have been. We didn't solve the root cause or anything, but we were able to gently detach one bit of code from a crufty old subsystem and unblock a Rails upgrade. And I think that that was plenty of accomplishment for 2 hours of work. I keep on stressing the time thing, because time is a proxy for our feelings too. When programming tasks take more time than we think they ought to, we feel frustrated and defeated and anxious. And we have to live with those feelings for the duration of the terrible programming task. And so there's been a backlash against Ruby metaprogramming and monkey patching, and all the things that make Ruby, Ruby, rather than just interpreted Java, because we don't want to have these feelings ever. These feelings are terrible. But when I gave an early draft of this talk at work, my boss pointed out to me later that my secret thesis was, in other languages, you solve things by building libraries, and in Ruby, you solve things by building programmers. In a lot of modern developer discourse, we talk about prevention and about saving us from ourselves. But there are two ways of doing that. We can do that by making our frameworks so restrictive that we can't possibly shoot ourselves in the foot, and spend our days writing boilerplate. This is ultimately an impulse toward controlling not only ourselves, but other people. It's about reducing ourselves and our teammates to nothing but cogs in a machine. Ruby's big secret is that it lets us save ourselves a different way. It lets us save ourselves from anxiety and feelings and other people's metaprogramming by empowering ourselves. And I like that story better. So I'm Betsy. I am currently an advisor. I used to be there full-time, but recently took a full-time position at the Long-Term Stock Exchange. I'm an advisor at Cohere, which is a consulting company that wants to make you a better programmer. If you want a 2-hour sharing session with one of my co-founders, like the one in which I solved the bug I talked about in this story, then you should go to wecohere.com and email them. And I'm sure they'd be delighted to let you exchange some of your money for their time. We also, if you're less commercially, have a newsletter that contains my co-founder Jennifer's thoughts on engineering and engineering management and how to be a better person and teammate. And this is not shameless self-promotion. Jennifer is amazing. You should read what she writes. Recently, Jennifer, Marlena Compton, and I also co-wrote a zine series called Let's Pair, which you can purchase at letspair.guide. And it's about being a pair programmer in a more friendly way, even if you're trying to pair across a skills gap, an experience gap, being a queer woman who's trying to pair with a straight man, things like that. Thank you.